Okay, we're on Chapter 2, Section 2.2, Part 2, Number 1. If x is the first of 4 consecutive odd integers, write the sum of the 4 integers as an algebraic expression in x. And the directions were to write the algebraic expression described and then simplify if possible. So first of all, what does it mean to be consecutive odd integers? It means you start out with one integer, which means not a fraction, and what's the next one? The next odd integer. So for instance, if the first integer was 5, the next integer would be 7, the next odd one would be 9, and the next odd one would be 11. If it was like a negative number, like negative 23, think about the number line, the next odd integer would be over at negative 21, then negative 19, and negative 17. So what you want to notice here is if you have an integer that's odd, the next one is 2 more. So notice you have to add 2 to get to the next integer. And that's the key here. So if the first one is x, then the next odd number is 2 more than that. So think of an odd number in your head for x and realize if you added 2, you would have the next odd integer. So the third odd integer would be 2 more than that one, x plus 4, and the fourth one would be x plus 6. So those are 4 odd integers. Now, we need to write the sum. Okay, it's asking to write the sum. So what is the sum? It means you've got to add the 4 integers together. All right, so let's see. We've got, these are the 4 integers. So the sum, you simply add them together. You are not writing an equation. You are just adding each of the integers. So we have x plus, now the next one, you would add the x plus 2, right? Plus, the next one would be x plus 4, plus, the last integer would be x plus 6. So if you want to see these as the sum of 4 odd integers, you could do this, or you could put parentheses around each of them, or you don't really need it since they're all addition. So what does that give me? If I add the like terms, x plus x plus x plus x will give me the 4x, and I've got plus 2 plus 4 plus 6 plus 12. So the simplified answer is 4x plus 12, if you define the first odd integer to be x. All right, we're still in Chapter 2, but we're going on to Section 2.3, Solving More Equations. Part 1, Number 1, 12x plus 7 equals 15x minus 5. So we have variables and constants on both sides of the equation, so we need to get the variables on one side, constants on the other. It doesn't matter which side you put the variables on. Here's one trick to making sure the coefficient of x is positive. Take the coefficient that's bigger, 15 is bigger than 12, and keep it on that side. So if I do that, I have minus 12x on each side so that I keep the variables on the right-hand side. So I have 3x, for instance, and notice you're not going to have any x term on this side, which means I want to then get rid of this plus minus 5. I only want a 3x on this side, so how about if I add 5 to both sides? So I'm adding negative 12x plus 5 to both sides of the equation, and I get 12 equals 3x, or you could have written that at another step as 3x equals 12. If you had kept the variables on the left and constants on the right, you would have ended up with negative 3x equals negative 12. All the signs would be different, but the final answer would come out the same. So I have 3x, I need to divide by 3. So I have 4 equals x, or you could write that as x equals 4, which is the way we normally would write the answer, so that our solution looks like it should be 4. Right, so we have to check it and make sure it really is. Easy to make a mistake, and that is what is so cool about algebra. You can check your work, and then if it's not correct, you can do it again, so you get the correct answer. So I have 12 times 4. We're replacing x with 4. And then we do order of operations. 12 times 4 is 48, plus 7, so that is 55. And on the other side, we're also going to plug in 4 for x. So that's, let's see, that's 60 minus 5, which is 55, and yes, got the same number on both sides. So when I replaced it with 4, we got a true equation. So that's the correct answer for number 1. All right, here's number 2. I'm not going to have room on this little area to put the check right next to it, so we'll do that at the bottom. All right, now notice we have on the right-hand side 9 plus x, and that's simplified. But on the left, we've got a parentheses, so the left side is not simplified. So our first step is to simplify this side. And remember, you have to think of this as a minus 2 times x or a negative 2 times x. So that's a negative 2x. And also a negative 2 times negative 1 will give you a plus 2. And then just copy the right side. And keep on going. This gives you, if you add like terms, you could write that as 10 minus 2x, or you could write negative 2x plus 10. All right. So I have 10 minus 2x equals 9 plus x. Now I have to put the variables on one side, constants on the other. Again, it's up to you which side you want to have the constants on and which side you want to have the variables on. I'm going to do the same method I did before. Since the coefficient on the right side is 1 for x and the coefficient is negative 2, this is the larger coefficient. 1 is bigger than negative 2. So I'm going to add 2x to both sides. So I'll have 3x on the right side, which means I don't want to have the 9. So I could subtract 9. Keep in mind there are lots of different ways to solve the same equation. This is just one way. So I get on the left-hand side just 1 equals 3x. So now I have to divide by 3 to solve for x. So basically that says 1/3 equals x, or if I turn it around, that means x is 1/3. So it looks like the solution, if I did it correctly, was 1/3. And the next thing will be to check it to see if that's the correct answer.